Welcome to solving radical equations and inequalities review. So I'm just going to give you guys some questions. You can pause them, try the problems on yourself, by yourself, and then watch the video and see if you did them correctly. So the first one I have up here is 3 minus 2 times the square root of x plus 6 is equal to negative 11. So to solve this one, we need to isolate the radical. So we're going to subtract 3 to both sides. And then at this point, we're going to go ahead and divide everything through by negative 2. And so we're left with the square root of x plus 6 is equal to 7. So we've isolated the radical. Now we can go ahead and square both sides. So we have x plus 6 is equal to 49. And then you can subtract 6 from both sides and get x equals 43. Now, with radical equations, we really do need to check the solutions by plugging them back in. Because it was equal to a positive number of 7, it should work out. But just to kind of remember that, to plug this back in, you're just going to plug it back in to the original, 3 minus 2, and then 43 plus 6. That's underneath the square root, supposed to be equal to negative 11. So now what do we have? Well, we'll get 3 minus 2 times the square root of 49. 3 minus 2 times 7. 3 minus 14 is negative 11. So you can see that it does check. So my only solution on this one is x equals 43. Okay? So that is solving a radical equation. We could also do something with cube roots as well. But there's an example of a radical equation. So let's go on to another example. Let's do an example where we're going to get we're going to do an inequality. Let's do the square root of 2x minus 3 is less than let's say 4. Okay. Now this one is already isolated. I could have put some other stuff on there and then had you isolate it, but this one's already isolated, so we just need to go ahead and solve it by squaring both sides. So if we square the whole thing, we're left with 2x minus 3 is less than 16. Add 3 to the other side and get 19. Divide by 2 and have 19 halves. Or 9 and 9.5 either way. So x is less than 19 halves, but is that my only solution? Are all those solutions going to work? Well, remember, your domain, whatever's underneath the square root, because the index is even, this is a square root, so because the index is even, we know that whatever's underneath the square root has to be greater than or equal to 0. We cannot take the square root of negative numbers. So now we solve this one, and we get values that are greater than or equal to 3 halves. So what does this look like to make sure that we're covering all our bases here? Is that we have 3 halves and 19 halves. So 3 halves down here, 19 halves over here. Values that are greater than or equal to 3 halves. But also we need the values that are less than 9 halves. So we have to be careful. Both of these things have to happen. Alright? We can't have all values less than 19 halves. What if we plug in 0? Alright, that's going to give you the square root of negative 3. That's not a solution. So we have to make sure we restrict our domain on this one. And so our final solution is all values greater than or equal to 3 halves and less than 19 halves. So at 3 halves, it is closed because at 3 halves, it's equal to. At 19 halves, it's open because right here it has that it's only less than, it's not equivalent to. So your final answer is right there. Alright, all values between 3 halves and 19 halves, including 3 halves. So there's an example of a radical inequality. And then let me go ahead and do one more, I'll do one of the more challenging ones of the radicals where you have to isolate both of them. And I'm going to pull this one just from the homework, so if you want to go back and look at the homework, you can. I will do problem, let's see, what if I do problem number 8 on the homework? So this is going to be number 8 from the radical homework. Okay. So we have the square root of x plus 2 minus 7 is equal to the square root of x plus 9. So remember, the first step is to isolate. So we already have one that is isolated. So let me change colors so you can kind of see what I'm doing here. So we're going to square this side, which means all we're left with is x plus 9, which is good. But when we square the other side, this is a binomial being squared. So you have to square everything, which means you're going to distribute this out. You're going to have a binomial times a binomial. If you have questions about this, let me know. But I'm just going to go ahead and multiply as to taking that and squaring it. So that'd leave you with x plus 2 minus, I'm going to skip some steps here. Like I said, if you have questions later on, let me know. But minus 14, because it's going to be negative 7 times the square root of x plus 2 twice. So that'd be minus 14 square root of x plus 2. And then negative 7 times negative 7 is 49. So now we need to isolate our second radical right here. So all that other stuff we need to get over to the left side. So if we subtract the x, it's actually going to cancel. We're going to subtract the 2 and subtract the 49. So that'll leave us with negative 14 times x plus 2 is equal to 42, I believe, negative 42. Alright, and then now we're going to divide everything through by negative 14, and we'll get the square root of x plus 2 is equal to 3. Okay, now we've isolated the second one, so now we go ahead and square again, and it'll leave you with x plus 2 is equal to 9. Subtract the 2 and you're left with x equals 7. It's a radical equation, so a radical equation you do have to check. You've got to plug it back in. So we're going to go back up to the original, plug 7 back in. 7 plus 2 minus 7 should equal 7 plus square root of 7 plus 9. So we get the square root of 9 minus 7 and the square root of 16. 3 minus 7 is negative 4, and that's supposed to be equivalent to 4, so obviously it is not equivalent, which means x equals 7. Our only possible solution is no longer a solution, and so what is our answer then? No solution. There's no value of x that you can plug in to make this a true statement. Okay, so there's just a quick video on dealing with radical equations, a couple examples of that. I didn't do any cubic, so we might need to go back and look at that. So we had a radical equation, and then I gave you an inequality to look at. Once again, if this was a cubic, the domain would be all reals. And then I gave you one that's a little bit more challenging in terms of the solving the radical equation stuff. So if you have any questions on this, let me know.